This video is all about ions, and we'll actually be using ions a lot more than regular atoms in chemistry. An atom is considered neutrally charged, which means it has the same number of electrons as protons. So the protons are equal to the electrons, and that's how it's neutral, or having no charge. Whereas ions will always have some sort of a charge, whether it's a positive or a negative charge. And this is because the number of protons will not equal the number of electrons. So either you'll have more electrons than protons or less electrons than protons. The next two terms that I want to talk to you about are cation and anion. I know that word looks like cation, but it's pronounced cation. Cations are ions that are positively charged. And the way I remember this is the T in cation kind of looks like a plus sign, whereas anions are always negatively charged. And the way I can remember this is because anion looks kind of like onion, which has a negative connotation. Typically, nonmetals will be anions, and almost always metals will be cations. And again, I like to use the T in metals to remind myself that metals will act as cations and will almost always be positively charged. Ions are formed based on kind of the cool group on the periodic table, which is group 8A, or the noble gases. As I told you before, noble gases have a very favorable electron configuration. There's just something magical about having the number of 2 electrons, or 10, or 18, or 36, or 54, or 86. So just about all atoms want to have that same number of electrons. Let's look first at lithium. If you find lithium on the periodic table, you'll see that it has an atomic number of 3, which means it has 3 protons, and when it's neutral, we know that it has 3 electrons. So it's going to start with 3 electrons. The way we figure out how many electrons are going to be gained or lost is with metals we will count backwards on the periodic table, and with nonmetals we will count forwards. Now we know that lithium is a metal because it is to the left of the staircase, so in this case we're going to have to count backwards to find the nearest noble gas. So remember that it's this group right here that are the noble gases. So that's kind of the cool group on the periodic table. Here's the element we're talking about right now, lithium. And let's count backwards. 3, 2, and you can see as soon as we get to 2, we've hit a noble gas. That means that lithium wants to be like helium. And so what lithium is going to have to do is throw away 1 electron. So lithium is going to lose 1 electron, and it still will have 3 protons, so it still has 3 plus charges, but when it loses 1 electron, now it will only have 2 electrons, or 2 negative charges. So you can do the math here and figure out that the charge of lithium is going to be plus 1. It's going to have 1 plus as far as its charge goes. The way we write that is Li plus, or Li plus 1, or we can even write it as Li 1 plus. Either way, any of those 3 ways is fine. This can be very confusing because lithium lost an electron, yet we are writing down a plus for the charge. The charge always goes in the upper right hand corner of the element symbol. Because it has a positive charge, lithium is a cation. In fact, almost all metals will be cations. So everything to the left of this staircase is going to be a cation. Okay, let's look at our next example, which is fluorine. Fluorine is right here. Now it is a non-metal because it's to the right of the staircase, and metals we counted backwards, which means non-metals we are going to count forwards. So fluorine is starting with 9 electrons, and we're going to count up to 10, and when we get to 10 we'll notice we'll hit a noble gas. We hit neon. So fluorine really wants to be like neon. In order to be like neon, fluorine is going to have to gain 1 electron. The way that we're going to write this is writing F minus 1. We can write F minus or even F1 minus. And so when we gain an electron, we actually write down -1. And let's look at the reason for that. Fluorine has 9 protons, which means it has 9 positive charges. And if it gains 1 electron, it's going to have 10 electrons. And if you do the math, you'll see that it ends up with a -1 charge overall. So that's why we have a -1 charge even though we gained an electron. So again, this is kind of confusing because it's opposite of what you would think. I had a student one time tell me that he thought of it like stress. He said if you pick up stress, you're more of a sad person or a negative person, whereas if you lose stress, you're a happier person. So if you're losing electrons or losing stress, you're positively charged. There's only one set of elements on the periodic table that don't really follow this rule, and those are these transition elements and these elements down here called the inner transition elements. So those don't follow that rule. They could care less about the cool group on the periodic table, and you have to be told how many electrons those are all going to lose. I say lose because they are all metals, which means they're going to be losing electrons. So they will still all be positively charged, but there's no way of looking at the periodic table and knowing right away how many electrons they're going to lose. And I'll show you later on when we get to chapter 4 how you'll be told how many electrons those are going to lose. One thing that you're going to notice if you try to figure out the charge of lithium, which we did, it's +1. If you try to figure out sodium, you'll see it's +1. Potassium is +1. Rubidium is +1. Cesium is +1. And francium is +1. What that tells us is everything in group 1A has a +1 charge. Everything in group 2, you may have guessed, is going to have a +2 charge. Everything in group 3, which is labeled as 13 on this periodic table, but it's this group right here, this is going to have a +3 charge if you're a metal and you're in group 3. Now if you're in group 4, you're going to have a -4 charge. That's because you're going to want to pick up 1, 2, 3, 4 electrons to be like the nearest noble gas. Everything in group 5A, which is the group for nitrogen, is going to be -3. Everything in the group of oxygen, which is 6A, is -2. And finally, all the halogens will be -1. Group 8A will not make ions. There'll be no charge there. It has the perfect number of electrons already, which means it doesn't want to gain or lose electrons. When you get a periodic table, again, you're going to always write +1, +2, +3, -4, -3, -2, -1, and nothing. That way you don't even have to think about this anymore. You can just look at chlorine and know, oh yeah, chlorine is going to be -1. Or selenium, oh, selenium is going to be -2. Or phosphorus, oh, phosphorus is going to be -3. Calcium is going to be +2. You don't have to do any thinking at all because all the numbers have already been written by yourself above the periodic table. So do this on every single periodic table all year long.